Hello everyone, good morning. So I will start with what were the motivations and the problems that made us develop OpenGHG. So we have countless data, countless gases, endless data, and on our vast planet. And this means that we need some kind of networks to gather this data. So we have multiple sensor networks situated around the UK and around the globe. These are called as DEC, EGES, NOAA. What they do is like they try to capture the real-time data of this multiple species. Once this data is gathered by these huge towers, they will provide us it in multiple data formats. And because of that, it arises the question of where and how to store this data. It also makes us think about the licenses and the attributions, and also the embargo that is applied on this data. Now, I will show you a quick dashboard that is developed by the data that was processed from OpenGHG. And here you can see the main plot that shows the comparison for the particular species for the years of data that was gathered for it. And all of this data that is plotted on the main plot is after it is been processed by OpenGHG, and it takes care of all the species that are handled by the DEC network. On the bottom right, you can see a map of UK, and these are the sites, and there are the specific inlet heights for which this species values are captured. Now, what OpenGHG does is that it makes sure to keep all the natural aspects of the data that was the way it was gathered, and then it processes it in a OpenGHG specific format. So this means that all the stakeholders that are working on particular research will have one specific data format for which they can perform their further analysis. This is just an in-depth information about the sites that are situated in the UK. This is a DEC network site. And it also speaks about its complex nature, its frequency at which the data was captured. It's the question that I asked before. And earlier how it was shared. It was usually shared using zip files or Dropboxes. So let's see what is OpenGHG. So OpenGHG has multiple functions that allow us to interact with these networks. One of that is this retrieve function. This retrieve function directly retrieves the data from the specific sites or the portals that we have, and it standardizes that data in an OpenGHG specific format and stores it as an object in our object stores. The standardization function is basically we perform data wrangling or data formatting on it, and we make sure that it handles multiple data formats. And then this data is stored in the data sources along with the metadata that we got from these sites will be stored in Metastore. Okay. So what are these data objects? So these data objects serve as a foundation to perform the analysis and visualizations. They are basically, we can search them using the specific keys that were supplied during its initial processing. And these data objects can be of multiple data types that are mentioned on the screen, which is surface, footprint, flux, and boundary conditions. And all of these together are then, all of these data objects are then together combined to perform the forward analysis. And also we can have multiple visualizations captured out of it. What are the additional OpenGHG features? The additional OpenGHG features is that we can have a custom data processing module. So if any researcher has its own data captured in his own way and he wants to make sure that it is then served by the OpenGHG, then he can either request for it or create his own PR. We can also compare between the surface, mobile, aircraft, and satellite data. So the reason to mention this is that all of these are captured in different formats, and we have to perform multiple calculations to make sure that they are in one specific unit and specific data format. What OpenGHG also has is the ability to interact with multiple stores. So there are multiple object stores, and we can perform inverse analysis and visualize it. So what are data sources? The data sources have data and attributes part. The data is actually has 3 different dimensions: latitude, longitude, time values, and the attributes are kind of keys that help us to identify them. One of the 3 main of them are site, species, and inlet. So anyone can categorize their data and search based on these key values. And also these particular data objects can then be formatted and provided, gathered in a netcdf format. And all of them are a CF compliant format. So that is just a norm within the atmospheric chemistry that they have to follow. And these data sources have multiple versions. So say that in the first month of the particular year, we had a file provided by one of the networks, and they thought that we need to have more updates in that particular file, and they release it in the next month. Then we will have multiple versions of that same file mapped by those 3 values in the data sources also. Right now, by default, we can access the most recent values, the most recent version, but we are also working to make sure that we can add a specific version and retrieve the data from that. So recently we applied ZAR on our data objects that were created on our data sources. It allowed us to chunk the data across multiple dimensions and helped us to control the amount of memory that we were using. And after doing before and after comparison of the application of ZAR, we found that there was 99.93% decrease in its memory usage, which was a significant development, because for the high frequency data that is gathered, there was a memory issues arising on the HPC network, but with this, those were resolved. This is also one of the output of OpenGHG. What it does is that all the data objects that are stored in the object store can then be converted into a netcdf file and shared amongst the stakeholders so that they can perform their further analysis on the netcdf file that was generated from the OpenGHG. GEMA is one of the recent success stories of application of OpenGHG, where we are providing the measurements analysis and to the UK government's Department of Energy, and then they are using it to compare against their estimations, and and it is helping them to direct the development of further policies in terms of atmospheric chemistry. These are some principles that are in focus, so which are also in line with the RSE 24 principles. So it is reusable. All the data is secure, stored on the HPC networks. For example, the Jasmine network, which is being handled by the government. The software itself is maintainable. We are following all the responsible practices, and anyone around the globe can install this OpenGHG software, and we follow all the ethical norms that are required. These are some of the building blocks that help us structure the OpenGHG framework. And right now, we are in progress to add an ability for a user to specify his own keys and label that particular data object as he wants. And we are also moving to a config file setup. So in config file setups, a user will specify the key values that he wants in a particular YAML file, and that's it. He just has to interact with the command line interface. At the moment, user needs to call a specific function from OpenGHG and then supply the argument values, but this will eliminate that particular process. And we are aiming it to be more expandable and in the future also. So that was all from me, and if you want to get in touch with us, need to know more about OpenGHG, you can follow these links, email me, or come say hi to me in the breaks that we have all along the RSE 24 sessions. So thank you very much.
Thank you very much, Prasad. If you have any questions, please make sure to put them in the canopy.
Teething problems.
Oh, okay. We're not going to get them up onto the big screen, but yeah, I have my wonderful assistant. First of all, where do you source your data from?
So as I mentioned, these multiple sensor networks provide us data from their portals. Some of them provide us a downloadable link. Some of them have their FTP servers, so we can directly fetch our data from them.
Thank you. And which language has OpenGHG been written and coded in?
So OpenGHG is written in Python language, but the dashboards and all those are written using React JavaScript framework. Yeah.
One more question. Does OpenGHG store or cache the data in a central cloud location, such as an object store, after retrieval from the source and transformation to the common format? Or is the storage of retrieved and transformed data the responsibility of the user?
So this answer can be given in two parts. The earlier cloud part that is mentioned is the functionality is there, but recently we have found that there is not much, like the demand for it was reduced. In terms of locally sourcing, as I said, all of this is stored on HPC network, so user can have a small chunk of it on his local machine, but in actual we don't need to cache them because it will stay on the group workspace there itself. Yeah.
I think we have a couple more minutes for one last question. Are you using the Jasmine object store or a commercial cloud?
So Jasmine just serves as a platform where the data is stored. It is not a way of like creating an object store, but the objects once the data is fetched from the Jasmine networks to our local university HPC network, the object stores rely on that particular frame. Yeah.
Brilliant. Thank you very much. Let's give Prasad one more round of applause.
Thank you.